Chapter 6.4, we're working on basic shifts of exponential functions. So first, let's recall graphing 2 raised to the x and 1/2 to the x. So first of all, 2 to the x, we know this is an exponential growth function because the base is greater than 1. So 2 to the x, let's pick these values, -2, -1, 0, 1, 2, and 3. Then you plug these in for the x values. So remember, 2 to the 0 is 1. So it's always anything to the 0 power is 1. Then at 1, we have whatever the base is, which in this case is 2. Then 2 squared is 4. 2 cubed is 8. 2 to the -1, so anything with a negative exponent means it flips, so this becomes 1/2. Then 2 to the -2, that is just 1/2 squared, so therefore it is 1/4. So first let's graph the asymptote. The asymptote is the x-axis here. And then let's graph these points that we have. So 0, 1, and then at 1 we're at 2, at 2 we're at 4, and at 3 we're at 8. At -1 we're at 1/2, and then it goes down from there. So make sure you extend your graph all the way with a nice smooth curve through all of those points, and that it doesn't cross through the asymptote. So here is 2 to the x. And so let's take a look at 1/2 to the x. So this base is less than 1, and so therefore we know it's an exponential decay. So let's plug in some values. Let's do -3, -2, -1, 0, 1, and 2. So if we plug in 0, that is just 1. If we plug in 1, 1/2 to the 1 is just 1/2. If we plug in 2, 1/2 squared, that becomes 1/4. -1, so 1/2 raised to the -1, remember it just flips it, so it becomes 2 to the power of 1, or just 2. 1/2 to the -2, again, it flips it and squares it, so it's 4. 1/2 to the -3, it's 2 cubed, which is 8. So let's draw our asymptote. And then let's plot our points. So always at 0, 1. And then at 1, we're at 1/2, so it's whatever the base is. Then on the left, it is -1, we're at -2. At -2, we're at +2. At -2, we're at +4. At -3, we're at +8. And then draw the smooth curve all the way through. So when we're graphing the exponentials, just look at what the base is, first of all, and identify the transformations. So once you identify the base, draw the parent function, depending on what that base is. So we're going to see different ones on the next page, but let's take a look at what do the transformations of these look like. Now, just remembering what we know about transformations, let's see if we can identify these. So we have 2 raised to the x plus 3. Now, number 1, we're looking at the parent function y equals 2 to the x. The base is 2. So remember, that is this graph right here. 2 to the x, we've graphed it already. So what does it mean when I have a +3 here with the x? How is this translated? Well, if you remember, if it's with the x, therefore it is a horizontal translation, and +3 means it is left 3. So let's graph the parent first, 2 to the x. And so let's draw our asymptote here. So 2 to the x, remember that is at 0, 1. And then 2, if it's base 2, then we know we're at 1, 2. And then we can plug in one more. 2 squared is 4. If we go to the left of the y-axis at -1, when x is -1, we get a 1/2. So here is the parent function f of x, or let's just say it's 2 to the x. So now we want to move it left 3. So in order to move it left 3, we're going to move everything left 3. Now, if I move my asymptote left 3, does that change? No, it's still on the x-axis, so that does not move. But every other point does move. So we're going to move everything left 3 points. So I'm going to start with this point here, the 0, 1, and move it left 3. 1, 2, 3. So then I plot that point here. Then you can either, if you can see the pattern and you can copy this pattern here, then you can do that. Or you can just move every single point left 3. So here I move that left 3, 1, 2, 3, and it'll be here. This one will be left 3, 1, 2, 3, and it will be there. So that's maybe one of the fastest ways to do it, but it's up to you. You have a choice as to what you decide to use on how you move it. Now this one is at a half, right? But it's still at the half, left 3. So it'll be still at the same point. So here's our graph of 2 to the x plus 3. Now let's look at 2 to the x and then plus 3 on the outside. So hopefully remember that is up 3. So let's graph our parent first of all. So the parent graph with the asymptote is here. And we know that the parent will be at 0, 1, and then at 1 we're at 2, at 2 we're at 4, and then we're at a half down here. So here is 2 to the x, the parent function, and we're going to transform it up 3. We move everything. So even thinking about the asymptote here, so that's going to move. If we move up 3, yes, that does change. So let me make it a different color. So we're going to move the asymptote up 3. Okay. And then we're going to move each of those points of the graph up 3 points. So if I start from here, I just move it up 3. 1, 2, 3, and the other one's up 1, 2, 3. So move every single point up 3. And then there is our graph. That's all that'll fit. So when we're shifting up or down, that is when the asymptote changes, right? And you can see that if we move the asymptote left or right, in this case, it doesn't move. So see if you can try it. Y equals 1/2 x. So again, the 1/2 x, here is the parent graph on the left, but I can start graphing that for us. So here is the asymptote for the 1/2 x. So this is at 0, 1. At 1, we're at a half. At -1, we're at 2. And at -2, we're at 4. And here is the 1/2 x, just the parent of 1, or the function 1/2 x. And remember, it's right here, right? So we did that work on the left already. So hopefully you see where the numbers come from. So that's the same for both this one on the left and this one on the right. And then see if you can try these out. Okay, hopefully you were able to get these graphs. So this is shifted right to, it's with the x. So every single point is moved right to. The asymptote, if you move it right to, it doesn't change. Then for this one, it's down 5. So move the asymptote down 5, and every single point down 5. And so that's how we get the point.